What's going on, everybody? Jonathan here. Another video today. I'm back here at this small little side job I'm doing, replacing some lights, including this wonderful 8-foot track light. Now, these are using halogen bulbs, MR16s. They're going to be replaced with LEDs. I recommend to just trade out the heads, but she wants the whole track taken down and replaced for her daughter's room, so I have it. And yes, this is a pre-war building. This is a concrete deck ceiling. So right now I'm waiting for these kitchen lights to cool off, because these are also halogen bulb lights, or they're cooling down right now. And in the meantime, I'm going to replace the 3 smoke detectors. I did one already. Brand new smoke detector, hardwired right here. Power's still off, but I'm going to try to check and see if the other one in her daughter's bedroom is on the same circuit. Alright, so this is her daughter's room. Smoke detector's inside right above her door. I'm going to check and see if the wires or the conductors are energized. Looks like there's a lot going on in there, and it looks like oh yeah, we got a pigtail splice. So alright, let's go whip out the KleinGuy circuit breaker finder. Alright guys, so I'm taking out the KleinGuy KT30 1P digital circuit breaker finder receiver. Now this also acts as a non-contact voltage tester, and it senses that there's current on the conductors right here at the tip or the nose of the receiver. So we're going to turn it on. Boom. Right now we're going to hit the NCV, non-voltage contact tester. There we go. So now it's on NCV mode. So we're going to check to see if there is power or current in those conductors. Alright, so we got a pigtail connection here. We got hot, and we got, let's see what we got here. It looks like we have a red wire, but this looks like a pass-through. Alright, we are. Here we go. We're going to test this out. Oh, yeah. We got power. So this guy looks like this one's a pass-through, so it must be feeding something else. Yes, it is. Okay, so we're looking for this one right here. And they are sharing neutral. So that means something else is tied into the neutral. We're going to have to find both circuits. Alright, so it's time to remove these guys. I hate when people put tape on these splices that's not necessary. Ah, here it is. Found it. Found the line. It's just stranded wire. It's not necessary, but they did. Here we go. Control. Huh. Interesting. So we got oh, here we go. No, never mind. If I turn it on. Alright, so we gotta open. Okay, ground. So let's test it out. Okay, so the panel next to me where I'm working. Boom. Boom. As you can see, it's a steady red light on the transmitter. I'm going to see if we can find it in this panel. One scan to study it. Alright. Nice and easy. Circuit 18. It's definitely not on this side. So we're going to try the even numbers. Looks like it's getting closer and closer. And it seems like it's 18, so let's give it a shot. Well, it looks like it was in circuit 18, because as you can see, the light's not flashing, and it's still taking a reading. We had a false reading. But another way you can find out is, and I figured this out with other circuit breaker finders, that if you can get a reading that is not 100% accurate, but the closest one you can get, So for instance, this one's reading it. And as you can see, it's picking up a reading somewhere here. So between 15 and 14, but 14 says smoke. So let's try circuit 14, which says smoke detectors. And we're going to try it now. And sure enough, that was it. Let's get to replacing the smoke detector. That done. Always remember that neutral could still be live, so we're going to have to find out where exactly this circuit is going. Now, I can find out if it's still energized by using the non-contact voltage tester on this, so on the receiver. So, and yes, there's still power there, so we can still find where that circuit is, because now they're sharing a neutral. Now untie this. This is still live. So you got this guy, and as you can see, it's not flashing, but it's reading voltage on that wire that's passing through, so it's sharing a neutral. The red and black conductor or wires are being used for two different purposes, but they share off the same neutral. That's what they used to call an Edison circuit, but this is a multi-branch circuit. So normally you have to put a two-pole breaker in the panel, but in this case there isn't. Whenever you're doing multi-circuit branch wiring like this, you need to have by code a two-pole breaker in the panel for it. That way you can simultaneously shut off both circuits that are sharing this neutral. If you disconnect the neutral while live, and you have both the black and the red live, you're going to cause the circuit to go on 240 volts passing through, or 208 volts. In this case, I think this building, these apartments are on single phase 208 and here in Manhattan. So you're going to end up having a 208 volt circuit passing through to anything, to your ACs, your outlets, anything you got plugged in. And what happens is you damage the equipment. I'm going to start from left to right. You want to scan, let the receiver study the panel. Now say it's circuit 5. It's saying circuit 5, but let's see if it is circuit 5. Bam, it's circuit 5. Yep, done. Right? Black and red. Right? Because this is a pigtail. Full disclaimer, this is not a training video. So sorry guys, I didn't have much left of memory of recording. So this photo here is what the smoke detector looked like before without the head. It didn't have a head to it. And yeah, it was pretty simple. You guys saw how I did it using the KleinGuy digital circuit breaker finder. And this is after, brand new. In the photo, the power is off. You don't see the green light in the middle. But I was able to re-energize it, test it. Worked out beautifully. So guys, just remember, this is not a training video, but just to kind of show you how to operate a circuit breaker finder, how to work safely around electrical or electricity. So for you DIYers, please pay close attention to what you're doing. But always, if you're unsure, contact a licensed professional, a licensed electrical contractor. Alright, so guys, thanks for watching. And yeah, see you guys in the next one. Take care.